start regarding that event loop, okay, in JavaScript. Okay, the before diving into the event loop, so we need to know regarding the JavaScript. So basically, the thing is, we need to know understand the fundamental concept that make the event loop works. Okay, the thing is like before that the JavaScript is the single threaded. Okay, JavaScript is the single threaded. Okay, so single threaded in the sense the JavaScript run on the single main thread. Okay, it means it can only execute the one task at a time. The single threaded in the sense the JavaScript runs on the single main thread. Okay, and it means it can only execute one task at a time. Okay, and suppose um, the thing is like if the task takes too long, it blocks the execution of the other task. Okay, so for example, so here we have the set timeout function. Set timeout function. Okay, after that we have the console.log, something called the that hello. Okay, so in this thing so that execution start from the top. Okay, it will come here. Okay, so imagine the set timeout has some delay, it's a 5 second. Okay, so till that thing that console.log need to wait for the 5 second. Okay, if the task takes too long, it blocks the execution of the other task, so it's taking two time. Okay, for that thing we can say that blocks are the blocks the execution of the other task. Okay, the JavaScript runs on the single main thread. Okay, so we can say this is the main thread. Okay, that set timeout and console we can set the main thread. It means it can only execute on one task at a time. Okay, so here that set timeout will work like the console.log it will work after completing the set timeout. Okay, but here set timeout we have the 5 second delay. Okay, so here it blocked the execution of the other tasks. Okay, so this is why the JavaScript uses that asynchronous model to help with the help of the event loop. So till now we have used that word called asynchronous model. Okay, the basically the asynchronous model with the help of event loop. So in this picture the event loop will come. Okay, the thing is like the event loop in the sense. Okay, so we have some such components in that event loop. Okay, the first thing sorry, 1 minute. So this is the our execution process. Okay, okay, so we have one call stack. So this is our call stack. Okay, and after the call stack, so we have one more component called web APIs. Okay, so the web APIs we can create here. Okay, after web APIs there is one more thing, that is a callback queues. Okay, callback queues. Okay, callback queues. Okay, then here we have sorry, yeah, so here there is a one thing actually. 1 minute, I have to check that one. leave it. So this is the okay, so this is, we can say this is the event loop. Okay, we will name the components. The first thing, this is the call stack. Okay, call stack. Okay, and this is the web APIs, web APIs. Okay, and this is the callback queue, callback queue. Okay, and this is thing, we can say it's a event loop. Okay, the first thing, so we have, like, we know that what the JavaScript is. The JavaScript is a single threaded. Okay, the single threaded in the sense that it runs the single runs on the single main thread. It means like it can only execute one task at a time. Okay, suppose that it task takes too long. Okay, it blocks the remaining task actually. Okay, for that thing we are using that, like, the JavaScript uses that asynchronous model with the help of this event loop. So this entire, this structure, we can say it's an event loop. Okay, in this thing we have some component that call stack and web APIs, callback and event loop. Okay, so we need to know what is the call stack. Okay, so basically the call stack is the data structure. Okay, that follows the, 1 minute, yeah. Okay, there is a call stack. Okay, so call stack, we can say it's an execution task, a stack also. Okay, so basically that this call stack is the data structure. Okay, that follow the LIFO in the sense it's a last in first out. Okay, suppose when the function is called, it get pushed onto the tasks, like stack. So suppose for example, imagine, so here we have one function called. Okay, so here we have one function, the function, uh, first function, first, this is the first function. Okay, I will console.log, this is the first function. Okay, and same thing, I have to create one more function. Okay, this is the second function, and here I will console, this is also second. Okay, so we have the two function, I will call those function. Okay, this is the first. Okay, and this is the second. Okay, so here I have to give that thing. Okay, yeah, imagine, so we have the two functions. Okay, so when I function the call, like when I function is called this first and second. Okay, it get pushed onto the this tag actually. Okay, so when I run this function and it call the function, it will come into this call stack. Okay, the first step come into this call stack. Okay, when the function is finishes execution, then it get popped from the stack. Suppose if we added the function, it's execute, we got the output, so then that function gets popped from the stack. Popped in the sense it will remove from the stack. Okay, for example, sorry, okay, suppose when I function, like when I call the function, the thing is like that sorry, okay, okay, like when a function is called, then this function get into the this one. Okay, okay, why it's not working actually, what happening here? It comes into the call stack. Okay, so when the function finishes the execution, it get popped out from the, like it get popped out from the that stack. Okay, so for that thing, so we'll get the output in the, like in the console. Okay, here you can see that the first function added to the task. Okay, and that added to the task execute that first function is execute and removed from the stack. Again, after the first function, the second function will add it to the task. Okay, and executes and remove from the stacks. Okay, now the stack is empty, means after executing the second function, so the stack is empty, so I have to remove the stack. Okay, so this is regarding the stack. Okay, call stack. So basically, call stack is the data structure, okay, that follow the last in first out. Okay, so when the function is called and it get pushed in onto the stack, when function is finished the execution, and then it get popped from the stack. So this is the working about the call stack. Okay, so the next thing we need to know regarding the web APIs. Okay, so web APIs, the one more name, like sorry, yeah. So web APIs, we can say there is a browser API, like browser APIs, for example. Okay, so basically the JavaScript does not have the timer, the normal JavaScript. Okay, the timer in the sense there is a, yeah, set timeout. Okay, the normal JavaScript does not have the timer, means the set timeout and DOM manipulation and HTTP request by itself. So JavaScript does not have those things. A set timeout, DOM manipulation, and that HTTP request. Okay, so the basically the browser like the provides the web APIs. These web APIs, browser provide the web APIs that handle the asynchronous task. Okay, so here you can see that's the next thing. There is a web APIs. Okay, so basically that JavaScript does not provide the any timer, DOM and HTTP kind of thing. Okay, but the that web APIs that handle the asynchronous task from the browser. The browser provides the web APIs. Okay, what are the web APIs in the sense? There is a set timeout and set interval. Okay, and the fetch and the DOM events in the sense, you can say, you can take that click event. Okay, click event handler kind of things. Okay, and there is one more thing, there is a ajax call, means HTTP kind of things. Okay, so when the asynchronous functions like a set timeout is called, it handled by the web APIs. So for example, so in this thing, in between the, so suppose we have the two function, in between the two function we have some set timeout. Okay, imagine we have the set timeout in between the two functions, function 1 and function set timeout and the function like function 2. Okay, so suppose if you have any the web APIs or browser APIs, so it will come into the web APIs component. Okay, so when the asynchronous functions like set timeout is called, okay, it is handled by the web APIs, not the call stack. Okay, so these all are these all things handled by the web APIs only. Okay, yeah. The next thing, there is a callback queue. Okay, callback queue, we can say the task queue also. Okay, the callback queue basically it store the callbacks that are ready to executed after their respective asynchronous task finish. For example, so yeah, for example, you can see, so there is a set timeout, okay, with a 5-second delay. So it will go into the web APIs. Okay, it will go into the web APIs. Okay, so after delaying, after delaying, it will store in this queue, callback queue. Okay, it's stored in the callbacks for the ready to execute the after their respective asynchronous task finish. Okay, so it will come here. Okay, after that the event loop, basically this event loop picks the, like it pick from the callback queue this task. Okay, push into the call stack when, okay, like into the call stack only when the stack is empty. Okay, the thing is like, suppose this call like the callback queue, basically this callback queue is store the callbacks that ready to execute the, after their respective asynchronous task finish. Okay, suppose if you have finished the delay 5 second, it will store here in the queue. Okay, after queue, so that this event loop checks, okay, if the call stack is empty. Suppose if the call stack is empty, then this event loop will pull that set timeout and push into the call stack. Okay, so this that event loop work like this actually. It will take the function from the callback queue and it will push into the call stack when the stack is empty. Okay, so in the callback queue there is a one more thing, the micro task queue. Okay, the micro task queue in the sense, we can say, 1 minute, I will write here. There is after web APIs there is a callback queue, and after that there is a micro task queue. Okay, so you can see that in the micro task queue, okay, we can see there is a priority queue. Priority queue. Okay, the some asynchronous tasks have the higher priority than others. Okay, the micro task are pushed into the separate queue actually. Okay, called, we can say that, uh, 1 minute, 1 minute.
Waiting, yeah.
Sorry. Okay, so the micro task queue, basically we can set the priority queue. Okay, the thing is like some asynchronous tasks have the some highest priority. Okay, for example, we'll take the example for the promises. So promises we can take the highest priority to compare that web APIs. So suppose if we have that suppose if we have some delay for the set timeout to compare the promises, so the promises we can take as the highest priority and uh, to push into the call stack. Okay, the basically that micro tasks are pushed into the separate queue. Okay, that call we can say micro task queue. Okay, for example here we can say, sorry, am I audible?
Yes, sir.
Okay, sorry. Okay, that micro task queue, basically you can say that is a priority queue. Okay, like some asynchronous tasks have some highest priority. Okay, so basically that micro task are pushed into the separate queue. In this thing there is separate queue. Okay, we can say that micro task queue. Okay, for example micro task queue, we can take the example for the promises. Okay, the promises. So in the promise you can see the dot then a dot catch. Okay, so here that micro task always run before the normal callback queue task. Okay, so this is regarding the entire that call event loop procedure, like it's a loop. Okay, the basically the event loop, the complete process, we can say that event loop continuously check if the call stack is empty. If the call stack is empty, if there any pending task in the callback queue, if there are any micro task to execute first. Okay, so this is regarding, we can say it's an event loop. Okay, we'll do some coding on that event loop. Okay, so there is a JavaScript editor. We'll take this one. Okay, so here I'll console the things, console.log, there is start. Okay, and here I will use the set timeout, and here I will console.log, it's the timeout callback. Okay, so I will add the 0 second. Okay, and here I will use promises to resolve. Okay, I'll use the dot then process to handle the promises. Okay, I will console.log. Here I will add the string as the promise result. Okay, and after that there is a console.log and end. So here you can see, here you can observe the that event loop. Okay, the thing is, yeah. So here I will run this code. Okay, here you can see the console.log is the start first, like it will execute the first. Okay, it will take the console.end directly because of so these two are in the like web APIs. This is the web APIs. This like this promises, we can say it's a priority queue in the sense that micro task queue. Okay, the basically that call stack in the call stack execution, you can take the example this one and I'll use here copy paste. Okay, so we have this example. Okay, this is a call stack execution. So first that console.log, okay, it will print. Okay, it will go into the call stack and it will print. Okay, so we don't have any other delay. So in the set time mode, what we'll do, that set time mode will send to the web APIs. Okay, into the web APIs. Into the web APIs. Okay, it's not executed immediately. Okay, and the thing is, like in the this like these promises will give the queue. Okay, and like till that console.log end will print. Okay, so here in the output we'll see the first thing we will get, the output is the start. Okay, so this set timeout and promises will go into the web APIs and queue. Okay, till now that end will print in the output. Okay, now the stack is empty after adding the output at the end. So the stack is empty. Okay, so here compared to the set timeout and promises, okay, the micro task, the queue execution, we can take the highest priority. Okay, for example, there is a promises is resolved, is logged before the set timeout. Okay, you can see in the set timeout have the 0 delay second, and here also we like we don't have any time, like we don't have any delay, but the priority wise it will take the micro task queue execution. So promises will take the first. Okay, first it will go to the call stack and it will execute, and it will throw the output like promise resolved, promise resolved. So then after the like after promise resolved, that again event loop checks if that call stack is empty, then that set timeout will set timeout will push to the call stack. So then we can say that timeout callback will print, timeout callback will print in the output. Okay, and there is actually for the that where it is, yeah, for that micro task queue there is separate block here. Okay, so that this promises will store in that micro task queue. Okay, so basically the entire thing we can say that JavaScript is a single threaded, it meaning it executes the one task at a time. So basically the call stack execute the asynchronous code first. Okay, and the asynchronous task go to the web APIs. For example, you can take that set timeout and set enter and fetch and down. Okay, so after that we have seen that micro task queue. Okay, the micro task queue we can set the promises. Okay, has the higher priority than the callback queue. And the event loop, here you can see there is an event loop. We can say this is the event loop. It's ensure the smooth execution by moving the task into the call stack when it's empty. When the call stack is empty, then it will pull the task from the callback queue, push into the call stack. So this is regarding the entire process about the about that call stack. So do you have any doubt till now regarding the callback queue?
Yes.
What about Preetham? Am I audible? Okay, so I will ask something actually. Okay, the thing is we have one function here. There is a function. Okay, function name is the greet. Okay, function name is the greet. Okay, here I will console dot log I'll make it as hello. Okay, and there is one more function apart from that greet. The function name is okay, 1 minute, I'll remove this. Function name is the say by. Okay, so here I will console dot log, we can say it's a goodbye. Okay, so here I will call the functions like the first one it's a greet. Okay, and second thing it's a say bye. Okay, so after that I will console one more thing. Okay, console one more thing, it's a end. So can tell me also. Okay, so what is the output for this thing actually?
And
Okay. Mm-hmm.
hello,
Hello,
goodbye.
goodbye.
Sorry.
Hello, goodbye, then end.
Okay, how can you imagine? Okay, this entire process, that event loop, and try to explain me on the using that event loop what will happen using this code actually. I will give one hint. Okay, so basically this is the synchronous code, we don't have the asynchronous code. Okay, you can tell me what will happen. The first step, what will happen actually?
First priority is execute functions.
Okay, so here imagine, like not imagine, just you can observe, we don't have any web APIs, any call stack, like any micro task queues. Okay, just we have the normal functions and console. Okay, just you can explain me using that event loop what will happen.
First function will store in stack segment
Okay. Mm-hmm.
one by one. Then after when console is output, then stack will be empty.
Okay, the thing is like, suppose if we have the grid. Okay, so here for, yeah, suppose we have the grid. For example, I will create here. Okay, duplicate, and here I will imagine. So this is our code. Okay, okay, this is our code. uh, 1 minute. Function grid. Okay, so I have to remove this one also. So what I told, the first thing here, we don't have any asynchronous things, just we have the synchronous code. Okay, so this is the call stack, you can imagine this is a call stack. uh, Call stack, the first step. Okay, so we don't have any asynchronous things, so just we can observe in the call stack only. Okay, first thing, there is a greet. Okay, the greet. Okay, there is a greet function. Okay, it will push into the call stack. Okay, and yeah, call stack. Okay, then it will execute in the call stack, and it will give the output. It will give the output here, the output like the hello. Okay, so after that thing, the greet will pop from the call stack. Okay, so I will remove the greet, and I will push that say by function. Okay, so after popping the create function, we need to push the say by function into the call stack. Okay, so here that say by will execute. Okay, it will print the goodbye. Okay, good by, it's the second output. Okay, so after printing the things, okay, that say basically the say by popped from the call stack. Okay, so there is the last thing, there is the console.log n. Okay, so it will run that that console.log. Okay, and it will print in this thing actually. Okay, so we have the output, the hello, goodbye and end. So this is thing we can say it's the only synchronous code in the call stack. Okay, I will add the one more thing. There is a console.log. The first thing, there is a start. Okay, the second thing, there is a set timeout. Okay, and there is a console.log. Okay, this is set timeout. Okay, I will add some time, it's a 0 second, and here I will run console.log, it's a end. So please explain me using that event loop. So what will happen, what is the process, what is the flow using this code actually? So we have the console.log start, set timeout and console.log end. So what will happen? I need execution flow. So what will happen, the first step? Can anyone try? Kaustubh, Priyanka, Pritam. I'm audible?
Sir,
Yeah. Can you try this one in using that event loop? What will happen? Yeah, please try. If it is wrong, not a problem. Just have to try actually.
first start will be
Mm-hmm.
uh, pushed into the call stack.
Mm-hmm.
Later, in start will be the pop in the callback function.
Mm-hmm.
Output will be first will be start.
Mm-hmm.
Then after end will be the push into the call stack.
Mm-hmm.
Then
And before
after
that,
end
what
will
will
be the
happen?
stack will be empty. Remove the
No, no.
start.
Before the end. So what will happen in the set timeout?
After that end, set timeout will be executed.
No. What will happen in the call in the event loop actually? So in this thing, so what will happen this code actually? I will copy here. You can just imagine. Okay, so the first thing that is start. Okay, like you said, it push into the call stack and it will print and it will pop from the call stack. Okay,
Call stack.
what will second? What about second actually?
Second will be executed after that end.
Yeah, but what will happen in this thing? Set timeout something, like there is thing actually. It can just, what will happen before the end actually? So we have the three components: call stack, web APIs, and callback queue. What will happen for that set timeout?
Set timer will go to the web API.
Okay, the basically the set timeout will store into the web APIs. Okay.
Then after end will
Okay. Till now,
push
so
into the
that
call stack.
end will be pushed into the call stack. After printing the
Then
end, it like after printing the end, popped out from the call stack.
then after set timeout will be executed.
After set timeout will be called if the call stack is empty. So this is entire process, we can say it's a callback. Not callback, it's a event loop. Okay. So there is a third example. So there is a start and there is a set timeout. Okay. Set timeout. Okay. There is a one more console dot log. I will add that mid. Okay. After that there is the promises. Promise dot result dot then dot then that console dot log. Okay, this is the promises. Okay, so please tell me the output for this thing along with that execution flow using that event loop. So we have the 5 thing here. One, it's a console dot start, console dot log start, set timeout, console dot log mid, and promise, and that console dot log end. What will happen? Can anyone try?
So first start will execute it.
Okay. Yeah. Explain me along with that this thing. I will copy and paste here. Okay. It will have, okay, 1 minute. You can take like, yeah, you can do here only. Okay, try to explain me using that event loop. What will happen the first step? You can start.
First, it will print the start.
Mm-hmm.
It will print the start.
Yeah, before what will happen in that flow? Okay, yeah, first step it's print. Okay, after that,
After that, set timeout.
okay, set timeout. What will do?
Means it is scheduling that task.
Which? So we have the set timeout.
Like that run after the 0 milliseconds.
Sorry, I didn't get actually. Can you please? So we have the set timeout. What will happen the set timeout in this in this execution process? Am I audible? So this is the code. Okay, first is the start, set timeout, mid, and promise and end. Okay, so what will happen from the first step in the execution flow? Can anyone try?
The start will be the executed.
Okay.
Then after set timeout will be stored in the API. Then after mid will be executed. Promise. Then after promises push into the web API.
Not web
Then
API,
after
into the micro
call.
task queue.
Then after end will be executed. Then after promises will be executed. Then set timeout will be executed.
Okay, then what is the final output for this question?
Start, mid, end, promise, and set timeout.
Okay. Yeah, the same thing. I will add one more thing here. Okay, I'll add three set timeout. Okay, copy and paste and add here. Okay, three set timeout. Okay, I will add here 1000 and I will add here 2000 millisecond. So can anyone try for this question? So we have the three set timeouts. Can anyone? Am I audible?
So
Yeah, can you try?
first start will be executed,
Okay.
then after mid, end, promises, mm, then set timeout top
One minute.
0 time.
1 minute. I will do one thing. There is the set timeout 222 and there is set timeout 333 and this set timeout 444. Okay. What will the output actually? Can explain me with along with that flow. Tell me.
Then after start, mid, end, then after promises, then set timeout of 4.
Mm-hmm.
After that, 1 second, set timeout 3,
Okay.
and after that, 2 seconds, set timeout 2.
You mean start, mid, end, promise, and
Set 4,
4 and
3,
okay.
2.
Okay. Yeah. Okay, got it. So do you have any doubt regarding that event loop? Am I audible?
Yes.
Okay. So now we will go for the closure. So do you know what is the closure actually in JavaScript?
It is a function.
What function actually can?
Means it executed outside the scope, like a lexical scope.
Okay. The limit, the basically we can say this closure in the JavaScript one of the most key concepts in the JavaScript. Otherwise, you can say it's the most powerful the key concept in the JavaScript. Okay. So to understand the closure, okay, we need to first understand some fundamental concepts. Okay, the like the foundation of for the how that closure works. Okay, the first thing regarding the function, understanding the function. Okay, the basically first thing we need the function. Okay, so basically the function is, we can say, it's a block of the code. Okay, to block of code to design to perform the specific task, we can say function. For example, so there is a function. Okay, function. Okay, there is a great, there is a great console dot log. Okay, there is the hello, and we'll call function like great. So before that, understanding the closures, we need to know so fundamental the concept regarding the functions, like how the closure works, the foundation for the how the closure works. Before that, we need to know what is the function. The function is a basically block of code designed to perform the specific task. Okay, so here the greet is the function that prints the hello, okay, when it calls. Okay, and the second thing, so function can return another function. Okay, this is the first point, this is the function. Okay, and the second point, there is the function can return another function. Function can return another function. Another function. Okay, so basically the function can stored in the variable. Okay, and the function can be passed as an argument. Okay, and a function can return the another function. Okay, the basically in JavaScript we can say the functions are the first class citizens. Okay, in JavaScript the functions are the first class citizen. Okay, the first thing here we can say the functions can be stored in the variable. Okay, so here function can store stored in variable. Okay, and the second thing, there is the function function can be passed as the argument. And third thing, the function can return the other function. Okay, the function can returns the other function. Okay, so basically the function are the first class citizen. Okay, so the three things. So first function can store in the variable. Okay, and function can pass as an argument, and the function can return the another function. Okay, so we'll create here on function actually. So when we have one function, the function name called the outer function. Yeah, so there is a function. Okay, there is the outer function. Okay, so there is a we will create one more function inside this function. We'll return one more function here. Return the function, the inner. Okay, so here we will console something. Console.log. Okay, so here we can say it's a, yeah, that's the function. Okay, 1 minute. So we can take in, yeah. So this is our outer function. So we have written the one more function. Okay, it's a function name is the inner function. Okay, okay, we'll do we'll do one thing. So we can store the function into the one more variable. Okay, there is a my function is a variable. I will store that outer function inside the my function. Okay, I will store that outer function to here. Okay, so now I will call this function actually my function I will call. Okay, so basically that outer function is return the inner function, so which is called called using that my function. Okay, we'll see in the output what will happen. Okay, yeah, it's a function is printing. So this function is working. So what we have did here, so we have created one outer function and we have written the one more function. We are consoling something. Okay, after that we are storing that outer function into the some other variable and we are calling that this variable actually. Okay, so what we have written here, the first thing, the function can be stored in the variable and function can be passed as an argument and function can be written another function. Okay, so we have seen. The thing is, next we need to see regarding that lexical scope. Okay, first point we have understood that function, what is a function. Second thing, we understood that function can return the another function and also the function can be stored in the variable. Okay, so second point is done. And third point, there is a the third point. Okay, the third point we need to understand, we need to understand third point, we need to understand the lexical scope. Okay, so before understanding the closure we must understand that the lexical scope, what it is. So basically the lexical scope means function can access the variable from the parent function. For example, so here we have the function. Okay, this is the parent. Okay, so here I will create one message kind of thing variable. So here I will add hello. Okay, so inside that thing we have to create one more function. The function I will create this is a child function. Okay, here I will console that message. Okay, and I will call that function, that this child. Okay, and after that I will call that a parent function also. Here I'll call that a parent function. Okay, so basically what we have did, we have created one function. Okay, and we have created one variable and we have created one more function inside the parent function. Okay, and we have called the child function and also we have called the parent function. Okay, so here the thing is like about the lexical scope in the sense the child function can access the variable from the parent function. Okay, but the parent function cannot access the child function's variable. The scope is determined at a time writing the code, not a runtime. For example, so what we have did here, the thing is we are accessing this variable. Okay, from the parent to child. Okay, so means that this child function can access variable, this like can access this variable. Okay, from its a parent function. So this message variable in the parent function. Okay, and we are accessing that variable into the child function. So in the lexical scope we can able to access that variable from the parent function in the child function, but we unable to we parent function cannot be access the child function's variable. Suppose we have the variable here and we are accessing the outside the in like we are accessing in the parent function, so it cannot access. So this is thing we can set the lexical scope. Okay, so now we can come to the fourth point. There is the closure. Okay, so basically the closure means the closure happens when the function remembers the variable from the lexical scope even after that outer function has finished the execution. For example, so you can see there is a parent function. Otherwise I will create one more thing. There is a function, okay, I can say there is a outer function, okay. I will create one count is equal to 0, and here I will return the function called the inner function. Okay, I will count plus plus, okay, and I will accessing that count variable inside the child, like in inner function console.log, and here I will do the count. Okay, so now I will do one thing here. I will store that outer function to the one more variable, to the counter. I will store that outer function, outer function. Okay, so now I will call the counter here. What will happen? Script is not imported model. So there is the let a return function, outer function. What will happen here? Line number 9, the counter. One minute. This is the outer function. We have the count. I will returning the one more function. The function name is the inner function. Okay. So in this thing, so we are consoling the count. Yeah, so we are getting the output. Okay, so the thing is the definition for that closure. Okay, the closure the closure happens when the function is remembers the variable from the lexical scope, even the outer function has finished the executing. So here I will call the one more counter. It will increment by 1. Okay, it by 2. So same thing I will call one more time. It's a 3. So here that outer function, this outer function is called, okay, and it return the inner function. So in this thing, okay, so the outer function basically we like here we have called, and this outer function will return the inner function. Okay, so this outer function we have called, okay, and the outer function it returns the inner function. So here it will return the inner function even after outer function has finished the execution, but that inner function still has the access to the count. So here we have here you can see we have called, okay, even after the that outer function has finished the executing, but an inner function still has the access to the count. So for that thing that this happens because the closure JavaScript keeps the count alive inside the inner function. So for that thing I am calling again and again, it will increment by 1 1 1. Okay, so this is regarding, we can say it's a closure. For example, so I will give one real-time example for the closure. Okay, so the thing is like for example, imagine imagine you walk into the coffee shop, okay, and place an order, one cappuccino, okay, and the basically like the barista takes your order and gives you the token, Okay, the token in the sense we can the small number slip. Okay, so you then wait at the table, and even though that the barista has moved to the taking new order, they still remember your order when you when you present your token. For example, the thing is how can I tell? Okay, so there is a coffee shop. Okay, there is a coffee shop, that the copy yeah, there is a coffee shop. The coffee shop, we can say it's a outer function, outer outer function. Okay, so the coffee shop takes the order, takes your order. Okay, and second point, the barista remember your order. Barista means we can say it's the inner function. Barista, the, the person, we can say, huh? The inner function. Okay, remember your order. Okay, even though the barista move on to serve other customers, they don't forget your order, because of the token we can say the closure. So the third thing, you have the token. The person, okay, moves onto the other customer, but they don't forget to yeah, they don't forget your order because of, so there is a token. So token will handle everything, means that exact identity for that particular order. Okay, so that token we can say there is a closure. The token we can say there is a closure. So when you show that your token, okay, then that person will receive the order from the memory and it will serve you. Okay, so this is regarding, we can say it's a example for the closure. Okay, and the thing is so we have seen, okay, that closure. Okay, so the thing is there is a one question, so why we are using the closure actually? So what's the main thing? So till now we have seen the closure is basically closure is like a function, and function can return the another function, and there is a yeah, there is a understanding that lexical scope, after that is a closure. So why we are learning these things actually? Okay, basically the thing is so we have some common use cases, common use cases, okay, of the closure. Okay, so the first thing I can say, it's a data hiding. Means data hiding in the sense we can say it's a encapsulation. Okay, so basically the closure allow the creating the private variable which can't be accessed from the outside. This is the first point, this is the first advantage and first benefits, we can say it's a data hiding. Means we can able to create the private variable using that yeah, closure. Means the closure allow to create the private variable which can't be accessed from the outside. So here only you have seen, okay, so from the we can access the variable from the outside outer function, to the inner function. We can't access the variable from the inner function to the outer function. We can say that lexical. Okay, the first point for the use case, we can say it's a data hiding, means it's an encapsulation. Okay, the closure will allow to create that private variable which can't be accessed from the outside. Okay, and there is a next thing, there is a dynamic function creation. Okay, dynamic function creation. Okay, so basically that closure generate the dynamic function, so which here we have created this one. So this is a dynamic function basically. So closure only have that thing, it will like the closure have that access to create the dynamic function creation. This is the second thing. Okay, and there is a one more thing, avoiding the memory leaks. We are using the closure, avoiding a memory leaks by ensuring that closure are not holding the unnecessary reference. Okay, it will throw them the garbage collections like that. Okay, so this is regarding, we can say, is the closure. So do you have any doubt in the closure actually till now? I'm audible?
Yes, sir.
No, sir.
Okay, so basically uh, the thing is like the closure the provide the several key benefits, okay, in the JavaScript to making them that the main concepts in the programming. Okay, the first thing, that is the data hiding, means it's the data like encapsulation, means we that JavaScript will allow us to create the private variable. Okay, and second thing, we have seen that dynamic function creation, and third thing, there is avoid the avoid the memory leaks, we can say, otherwise avoiding the global variable. It will automatically clean the code, like for the cleaner code we can say that's avoiding the global variable. Okay, and there is a uh, fourth thing, we can say, the delaying the execution. Okay, and there is one more thing, there is a reusability. reuse reusable Okay, reusability. Okay, so these are the things we can say in the closure. Okay, the next thing we can see regarding that IIFE. So do you know what is IIFE? Am I audible?
Yes, sir. Yes.
Yeah. Do you know what is the IIFE? So why we are using it thing?
It's a immediate invoked function expression.
Means like yeah, got it. Okay, yeah. So basically that IIFE, in the sense, it's a immediately invoked function expression. Okay, so the thing is immediate immediate invoked function expression. Okay, IIFE, in the sense, immediate invoked function expression. Okay, so basically this function in JavaScript Okay, it executed immediately after the its like definitions. Suppose if I define the function, it will execute immediately. And basically it is useful when we need to create the separate scope for our code to avoiding the global namespace. Okay, so we need to know why do we need this IIFE. Okay, the first thing, there is avoiding the global scope pollution. Okay, why we need, in the sense, there is a one thing, avoid the global scope pollution. Okay, for example, imagine you are building the shopping cart any task, otherwise feature. Okay, so in the e-commerce website, okay, in e-commerce website you can see there is a product, add to cart, bill payment, all the things. We can see that the e-commerce website, for example, you can take that Amazon. Okay, so imagine you are building the shopping cart like Amazon. Okay, so you are like a shopping cart feature in the e-commerce website. So you have a variable for the discount and price. Okay, so basically you have the variable for discount and prices, but you don't want them to the to affect other part of our other website. Okay, so by using the IIFE, so you can keep these variable as a private. So for that thing we are using that, avoiding the global scope pollution. And second thing, there is the execute code immediately. Execute the code immediately. Immediate. Okay, suppose you want to slow a welcome message when the user visits your web page, but you don't need to the function after execution. But here we can use that IIFE is the best way to run this logic once and discard it. Okay, the basic syntax for that IIFE. Okay, so basically there is a function. Okay, function enclosed with the parenthesis. This is the first parenthesis we have to use. This is the first function, like first parenthesis we have to use. In that thing we have to create the function. Okay, and function, we don't have the name, actually function name. Okay, so yeah, so here I have to call function like without naming. Okay, so inside the block, so we can call console.log. Console.log, there is the hello. Okay, so this is the syntax for the IIFE. Okay, the function is enclosed with the parenthesis. Okay, and the another pair of the parent, like that brackets at the end of that execution, because of it will execute immediately. So the this first bracket parenthesis, it wrap the function to the make it an expression. Okay, and the second parenthesis, second bracket, calls the function immediately. Okay, the first function what will do, so it will wrap the function to make it an expression. So we have made some expressions. Okay, the second function will call the immediately. Okay, so we'll see in the code wise. So I will copy this one, I will add here. So this is the function. Okay, so this is a function, so you can see the output is the hello. Okay, so now we can see with the parameters. Okay, so with the parameters we have to create the IIFE. Okay, so we can pass the argument into the IIFE to customize. How means, So here I will pass the name, okay, and here I will do one thing, okay. So here I will make hello, hello. I will okay, I will add that a name, okay. While calling the function, here I will add that particular name, okay. The name I will add, yeah, the name I will add, there is a Virat, okay. Yeah, you can see, okay. So using the that parameter with the IIFE, okay, so we can pass the arguments into the IIFE using like this. Here we have to use the name, and here we have to pass that particular value, okay. So we need to know IIFE with the return value, okay. So basically an IIFE can return a value and that we can store in the variable also. For example, yeah, so there is a, I will store this one into separate variable, the const. I will add the discount kind of things, okay, discount, okay. There is a function I will pass, there is a price and the discount, okay. So I will return something here, I will calculate some discount. Actually there is a price, okay, minus uh, price minus a price into discount by 100. So I have created one discount, okay. And the thing is, like, for example, the price is 1000, okay. I will make a discount at 10%, okay. Then I will call that variable console.log and that discount, okay. So here what we have did, so the price is the 10 like price is the 1000, okay, and discount is the 10%, means so that you will get the discount as a 900. So using the IIFE we can do like this, okay. So this is the return function, like return basically return value using the IIFE, okay. So now we can see that IIFE with the arrow function. So basically we can also write the IIFE with the arrow function, okay. For example, I'll create the arrow function. First of all, there is a two thing, one, not this one. There is a two thing, one parenthesis, two parenthesis. One, it's a calling, one, it's a function, okay. In this thing I'll create the callback, okay, and I'll do one thing here, that is a console dot log, and I will make this is the IIFE, okay. So this is the simplest way to create the using the arrow function. This I simplest way to create that IIFE using the arrow function, okay. So this is regarding, we can say it's a IIFE, okay. But we have one question. So so we have seen why we need that IIFE, but so we need to know when to use that IIFE, okay. So the thing is, like, the first point, to avoiding the global variable conflicts, we have to use to avoiding a global variable conflicts, okay. So we can use to avoiding the global variable conflicts, okay. And the next point we can see, to execute the function immediately without storing it, okay. And third thing, there is a to encapsulate the logic that should not be accessible outside, okay. So the other thing, like we have to use that IIFE. And there is a one like there is a one thing. So don't do the mistakes at the end of the that function. So this is the mandatory, this bracket is the mandatory to add to calling that function immediate. So suppose if we are removing, so we'll get some error actually. The error is like expected assignment and function call. So that curly like that bracket is needed, that parameter like parenthesis is important to call the function. Okay, so this is regarding, we can say it's IIFE. Okay, so till now what we have seen. Okay, first thing we have seen that event loop. Okay, in event loop what we have seen, that the call stack, web APIs and call stack and Microsoft queue and that event loop. Okay, and after that what we have yeah, after that we have seen that closure. Okay, in the closure we have seen that and the function can return the another function. And third thing, there is understanding the lexical scope. Fourth thing, the final closure. Okay, after that we have seen that IIFE. Okay, so till now I have covered. So do you have any doubt till now regarding that event loop and closure and IIFE?
No, sir.
Okay, then got it. So we'll do tomorrow some different thing. Okay, we'll get some different concept. Okay.
Oh,
Okay, then right.